So our objective is to reimagine the software development lifecycle with LLMs. And we want the AI assistants to be highly integrated into the developer tools with a focus on empowering the human developers, not replacing them. And towards this goal, we propose natural language outlines, which is a conceptual foundation that is broadly applicable across all parts of the SDLC. We explore an umbrella of developer features that forms a vision about the future of software development. Prior research has shown that about 70% of developer time is spent on program understanding. So how can we make code easier to understand and navigate? Can we improve the code's organization and help developers collaborate with AI tooling more effectively? To do this, we were inspired by a few themes. First is the concept of outlining. A book or website can have section headings that can be interleaved with the text or shown separately in a table of contents. And when dealing with code, a list of symbols can help developers understand the code file at a glance. And all of these help with navigation too, with page numbers or hyperlinks that take you to the corresponding part of the document. Another theme is summarization. For example, research papers have abstracts that highlight the key ideas. LLMs can also summarize documents, including code files. Lastly, natural language. Good coding style incorporates natural language in the form of identifier names, docstrings, and comments, all of which help developers interpret the code. And literate programming in computational notebooks uses natural language to add structure and context to the code. We bring these themes together in the concept of natural language outlines. An NL outline contains short sentences or statements that partition the code into logical sections, and they summarize the main ideas in each section. On the right is an example where the NL outline statements are shown as comments with a special syntax, and they're highlighted in yellow. To really feel the impact of NL outlines, let's look at a direct comparison. Which of these, left or right, is easier to understand at a glance? On the left is real code that I wrote for a prior project. It's not that complicated, relatively speaking, but you still have to read every single line and make a mental model of each variable and how they change. And then you have to interpret what it all really means. On the right is an NL outline that says the same thing as the code, but in a format that's much shorter and easier to read, because the NL outline does all the parsing and interpretation for you. The one downside is, if you want more detail, then you have to go look at the code. So maybe the best of both worlds would be to put the NL outline into the code. And now the outline helps to organize and explain the code, and the code is still visible as the source of truth. NL outlines can be interleaved with the code like this, or they can be shown separately, like on the previous slide. But either way, they're designed to improve developer efficiency. And most importantly, NL outlines can be generated with LLMs, and therefore we can use them as a new modality for human-AI interaction. At this point, it might be easy to dismiss this as just generating comments. So before anyone gets distracted, let me clarify. Existing comments come in many forms, like to-dos and developer notes. But research has shown that existing comments are not correlated with actual or perceived code understanding. In contrast, NL outlines are specifically designed to boost code understanding, and they actually succeed at this according to our developer surveys. Furthermore, existing code comments are static, but NL outlines are meant to be generated and maintained by LLMs, so they enable new forms of human-AI interaction. NL outlines differ from docstrings because docstrings describe the function's contract to help users of that function, but NL outlines focus on the implementation to help the developers of the function. And if you ask an LLM to explain some code, typically you'll just get a large wall of text. No one wants to read this much in the middle of development. Instead, NL outlines are concise and aligned with the code. So now that we know what NL outlines are, let's talk about their use cases. First, NL outlines help with code understanding and navigation. This is best illustrated with this mock-up showing our vision for how NL outlines can be integrated into an IDE. On the left, labeled with 1, is a panel listing the symbols in the file with NL outlines for each function. On the right, labeled with 2, we have code with NL outline statements interleaved. 3 shows how the outline statements can be used for code folding, to collapse or expand regions of the code by concept, not by indentation. And lastly, 4 shows how the NL outlines can be used for navigation. The side panel emphasizes the current cursor location, and the outline statements in the panel can be clickable, so bringing the cursor to the corresponding part of the code. Overall, these features help developers think at a higher level of abstraction in English without getting bogged down by the code syntax. NL outlines also help with code maintenance. If you have code with NL outlines, you can edit the code and have the LLM update the outline, which then becomes automatic documentation that evolves with your code. Or you can do it the other way. Edit the outline and ask the LLM to update the code. And now you're programming with concepts in English. More generally, you can make changes to the code or outline, whatever is more convenient, and have the LLM finish the job, which means it identifies the intent behind your changes and propagates them downstream changes everywhere else. We built this idea into a prototype tool which we call Finish Changes. For example, suppose we have the code on the left. It loads some inventory data from a file and computes the total quantity of products. But if we change the code by adding the highlighted text, now it's a total value of the inventory. And with just that highlighted change, Gemini 1.5 Flash understands the intent and updates the rest of the code and the NL outline accordingly. So it replaces quantity with value, and it updates its type from int to float. As another example, the outline used to say, open the JSON file. But if we change JSON to CSV as highlighted, which is just a one-word change, now Gemini Flash updates the code to read from a CSV file instead. Finish changes can even handle multiple changes at once. On the left is the original code, and on the right we made 3 separate changes. And after invoking finish changes, the LLM finishes everything all at once. This is a real prediction, and it changed a lot of things, but it's entirely correct. Now let's discuss other applications across the software development lifecycle. Finish changes is great for editing code, but here's another approach for generating large amounts of new code. In traditional LLM-based code generation, the user describes the request, the LLM generates a bunch of code, and now the user has to review the code. But this can be surprisingly difficult, especially if the generated code uses some unexpected strategies. And if the code has some overall mistakes, then all of the effort is wasted. Instead, the LLM can first generate NL outlines describing the strategy and the structure for the new code. And this is much easier to review, and the user can edit the outline if needed. And only after the user approves the outline does the LLM generate code according to that outline. And now the code is more interpretable because the user already expects that strategy, and is more likely to be correct because the user approved the plan. And by using NL outlines as an intermediate checkpoint, we get better alignment between the human and the AI. Traditional code search uses regex-based matching, which only matches the code syntax, not the conceptual ideas. We can use NL outlines to enable natural language code search. If we generate and then index the natural language outlines for the code base, then we can support natural language queries by matching them to the indexed NL outlines. This lets us search for concepts like, where does my app handle user authentication, or for examples of using some API to do some action. Also, because code search results are isolated snippets of code, the user doesn't have much context. We can use NL outlines to summarize those code snippets and the surrounding code context, making the search results more interpretable. For code review, we can generate NL outlines for the old and new code, where the outline only differs where the code has changed. Then, the diff of the NL outlines becomes an English summary of the code changes that is also aligned with the code structure. So you can focus on the conceptual changes using the outline diff, and then you can maybe click on an outline statement to jump to the corresponding part in the code diff. Okay, that's a lot of applications. Let's switch gears and talk about generating NL outlines. We propose two techniques. The first we call interleaved generation. The LLM prompt contains instructions and a few short examples, and then we provide the code to the outline, and we ask the model to repeat the code, but with outline statements added as comments. This is pretty straightforward, but it has high latency because the model has to repeat all of the code, and the model might change the code, in which case we need some fuzzy matching to align the predicted comments with the original code. The second technique is called line number infilling. In the prompt, we provide the code annotated with line numbers, and we ask for the outline to be formatted as pairs of line number and outline statement. So this is much faster, but we get generally worse quality because the output format is less natural for the LLM. We ran some quality experiments where we collected a data set of 30 Python functions contributed by 6 Googlers. We ran a survey where we generated 10 outlines per function and had them rated by the function's contributor because they are very qualified to judge. Gemini 1.5 Pro with interleaved generation was the best combination we tried. Under that setting, 60% of outlines achieved the highest rating of excellent overall quality, and 90% were acceptable or better. 63% were rated as very helpful, and 80% were completely correct. Keep in mind, Gemini 1.5 Pro is over a year old at this point. Google has since released Gemini 2.0 and then 2.5 Pro, so quality is even better now. The point is, modern LLMs are already good enough for NL outlines to be viable, even in proprietary code bases that the models haven't seen before. Now I'll talk about two case studies, the first being in Android security, where reverse engineers, or REs, inspect decompiled code from Android apps so we can find and remove malware from the Play Store. The decompiled code is really difficult to understand because identifier names are removed and apps are often minified and obfuscated. We collected a data set of 80 decompiled functions from real Android apps. Half of them were labeled as suspicious because they had been previously flagged as containing malware techniques, and the other half were benign. We used an LLM to generate 3 kinds of predictions for each function. First, the suspicion score is an integer from 0 to 3 that quantifies how problematic the code is. The summary uses a few sentences to describe the code and its security implications, and we treat this as a baseline form of AI assistance. Finally, we generate an NL outline, which focuses only on explaining the suspicious parts. On the right is an example where the NL outline points out where the code accesses the user's clipboard and then sends its contents elsewhere, which is a privacy concern. We surveyed 30 professional reverse engineers. We found that the LLM predicted suspicion scores were very accurate, actually more accurate than the REs. When we asked the REs to rate the helpfulness of the different kinds of predictions, we found that the NL outlines were overwhelmingly preferred by the REs with the most experience, likely because they are the ones who make the final decisions for apps, so they need to be fully convinced of the code's behavior. And the NL outlines point directly to the suspicious parts of the code. The REs gave us feedback, including, the LLM help will change the game for us REs in speed, accuracy, and confidence. And score and comments are by far the best features. Summaries would allow quicker reviews, but it is necessary to have a look in the code where the comments would help a lot. Here, comments are referring to the NL outlines. The second case study focuses on code review of large change lists, or CLs, which is difficult because it's hard to keep in mind all of the changes. For large reviews, internal metrics provide evidence of reviewer fatigue and reduced review quality. Having multiple smaller CLs is much preferred, but this can be difficult for CL authors. To address this, we created a feature called Virtual CL Split, which partitions a CL's code changes into logical topics. It's virtual because it's just a view on the CL. It doesn't actually create smaller CLs. But once we have the split into topics, the reviewer can focus only on the changes within a selected topic. And in this way, they can review the CL topic by topic, much like reviewing multiple smaller CLs. To generate a virtual split, we first give all of the code diffs to the LLM and ask for a list of topics. Then for each file, we give the file diff and the topics list, and we ask for an NL outline of the diff, where each outline statement summarizes part of the diff and assigns the most relevant topic. Here's a screenshot of a virtual split. At the top, we have each topic displayed as a button. When clicking on a topic, the associated changes are expanded and unrelated changes are collapsed. So for example, here, the reviewer can see a new function and its unit tests and its usage all together without being distracted by any unrelated changes. Feedback for this feature includes, "This is amazing. It makes it a lot easier to review related changes across multiple files. It was easier for me to understand the change step by step. And it's already saved me time in code reviews." To recap, NL outlines summarize and organize code and act as a new modality for human-AI interaction toward the goal of improving developer productivity. They have many applications across the software development lifecycle, forming a vast space for future research. Thank you, and I'm happy to take